Welcome to our notes on conic sections and parabolas. Students will be able to create the standard form equation of a parabola, identifying properties such as the vertex, focus, focal length, or focal width after reading a guided text. Part 1. Read through and mark up the following text and table. A parabola is a set of all points in a plane equidistant from a particular line, which is called the directrix, and a particular point, the focus, in the plane. So we have two new vocabulary words we haven't heard of when we talk about parabolas, which is the directrix and the focus. So the directrix in both of these diagrams are as follows. It's a line. It's either a horizontal line if the parabola is facing up or down, or it's a vertical line if the parabola is facing left or right. And we also have our focus. The focal length P of the parabola is the distance from the vertex to the focus of the parabola, and it is also the distance from the vertex to the directrix. The vertex is directly in between the focus and the directrix. So the focal length P is this distance from the directrix to the vertex or from the vertex to the focus. Parabolas open upward or opens to the right if P is greater than 0, and will open downward or will open to the left if P is less than 0. The axis of symmetry is the horizontal or the vertical line that divides the parabola in half. That is what we're actually quite used to. It'll go through the vertex, so the axis of symmetry is here if the parabola opens to the left or to the right, or the axis of symmetry is here if it opens up or down. I'm just going to go ahead and highlight that the same color. Now, lastly, we're going to talk about the focal width, which is the length of the chord or line segment through the focus and perpendicular to the axis of symmetry. It can help us find two exact points on the parabola. So, for example, on this line, I have these 2 points here. If I draw a line segment between those 2 points, then the focal width is this distance right here. So focal width. There's actually a formula for that, which we'll get to soon. Same thing here, this point here, and this point here. Draw a line segment. This will be the focal width here. So I'm just going to go ahead and color that something different. So how about pink, because we haven't done pink yet. This whole distance is the focal width. Here's a handy table to reference whenever you are working with parabolas and you're trying to find the standard equation of them, which looks a little bit different than what we're used to because now we incorporated P into our formula. So we need to know what P is. The focal width can be found with an equation. The focal width is the absolute value of 4 times P. And the reason why it's absolute value is because we're talking about a distance. However, you need to be mindful as to whether or not P is going to be positive or if P is going to be negative. And you can determine that by looking at your directrix and the focus. If the focus is above the directrix, then your parabola should be facing up. If your focus is below the directrix, then your parabola should be facing down. If your focus is to the right of the directrix, then your parabola is facing right. And if your focus is to the left of the directrix, then your parabola is facing left. So you can figure out whether or not P is positive or negative from that. Okay, part 2. Let's look at an example. It says, draw and label the vertex, directrix, axis of symmetry, focal length, and focal width on the following diagram given that the focus is -2, 2. Write the equation of the parabola in standard form. So I'm going to mark up everything that I know. So right now I can easily find the vertex. I'm just going to write V for vertex because if we label all the points and everything, we're going to have a very cluttered graph. So -3, 2. I've been told what the focus is. The focus is -2, 2. So let me draw that in there. So I'm going to call that F for focus. The parabola faces to the right, which means P is going to be bigger than 0. The focal length is going to be the distance from the vertex to the focus. So that distance is 1, so p equals 1. Also, that p-value is also going to be the distance from the directrix to the vertex, so I can find my directrix next. My directrix is going to have the equation, I'm just going to use D for directrix, x equals -4. We can also figure out our axis of symmetry as it goes through the vertex and the focus. This is y equals 2, so I'm going to call that AOS. So y equals 2. Now the focal width, if I start at my focus and I move up to this point and I move down to this point, from a graphical standpoint, it will be, let's use a different color here, pink. How about pink? That distance, which is going to be 1, 2, 3, 4. So I should have a focal width of 4. Now from using the formula, which is 4 times p, if I replace p equals 1, I in fact do get 4. So you can use the formula to find the focal width, or you can use the graph if you have one to find it. So the two other points are the ones we actually drew when we were finding the focal width graphically, which is -2, 4 and -2, 0. So now we just need to put the standard form equation together. Since it opens to the right, we're going to use this form, y minus k. K is 2 squared equals 4 times p. Now this is like the focal width without the absolute value. So 4 times p is 4 times 1, which is 4, and then x plus 3. And that's that for example 1. Why don't you try marking up, drawing and labeling all of these characteristics of this parabola